I have been asked to provide a couple more examples of distance, velocity, and time calculations, so here's what we're going to do. Alright, so how does all this work? Time, distance, velocity, we've done a couple examples, let's do a couple more. So here's a problem. A problem. Let's say there's an asteroid out there. Suppose it's really far away. Suppose it's 7.2 away, a distance of 7.2 AU away from us. An asteroid is 7.2 AU from us. How much time does it take for light to get here from there? Or from there to here, either way. How much time for light to travel this distance? Okay, so there's a nice straightforward classic sort of problem. I want you to be able to do this. This relationship, distance, velocity, and time, you can get this. So what's going on? In this case, we have a number for distance. I'm asking for time. So the equation we need is time, if I can write properly, time equals distance divided by velocity. Again, this isn't just true in astronomy. If I need to go 200 miles at a speed of 50 miles an hour, how long will it take? 200 miles divided by 50 would be 4 hours. That's what's going on here. So what I want to do is I want to take this distance of 7.2 AU. I know the speed of light is 3.00 times 10 to the 5th kilometers per second. Am I ready for the calculator? No, because the units have to work out. I've got this distance measured in AU, astronomical units. The Earth is 1 AU, 1 astronomical unit from the Sun. But then the speed is in kilometers per second. So before I can do anything, first I got to take that distance in AU, got to convert the AU from lengths, distances measured in AU, to distance measured in kilometers, and then I can do the business. So let's do that first. So I need to convert 7.2 AU to kilometers. All right, so how do we do that? Well, first of all, I look up in the back of the book and I find that 1 AU equals 1.496 times 10 to the 8th kilometers. Anytime we do a unit conversion, I'm going to take that 7.2 AU, my basic number, and I'm going to either multiply it by the conversion factor or I'm going to divide it by the conversion factor. So, how do I know which one to do? Do I want to multiply 7.2 AU by 1.496 times 10 to the 8th, or do I want to divide it by it? Here's how to do it. We could set it up, and I'm going to guess, let's see, AUs are big, so that should be a lot of kilometers. So I would expect I'm going to multiply this across. Let's double check. 1.496 times 10 to the 8th kilometers equals 1 AU. I'm multiplying this by a fraction. These two things are really the same thing. 1.496 times 10 to the 8th and 1 AU, that's the same number here. That's the same distance, quantity, amount. And so if I multiply across, notice I have AU upstairs, AU downstairs, and so this is going to work. So in this case, I do indeed need to multiply. I'm not dividing, I'm multiplying. So I do 7.2 times 1.496 times 10 to the 8th. And what do I get? Okay, I get 1.08 times 10 to the 9th kilometers. All right. Very good. So now I have a distance where I can do this time calculation. Here, let's write it again. Time equals distance divided by velocity. If you want to know, if I'm asking you for, if you need to know an amount of time given a distance and a speed, that's what we do. We take distance divided by velocity. So I have 1.08 times 10 to the 9th kilometers. That's another way of saying 7.2 AU. That's the same number. I divide it by this universal speed of light, 3.00 times 10 to the 5th kilometers per second. And I go to my trusty calculator. For those of you at home, please play along with us. Get out your calculator. Make sure you can do the same calculation. If you can't, then get a hold of me. We don't figure out these silly calculator things. 1.08 times 10 to the 9th divided by 3 divided by 10 to the 5th, And what do I get? I get 13.7, I get time equals 3,600. Okay, I get 3,600. So what is that? 3,600. 36. What units would that be? Remember, no naked numbers. Every number in this class should then be accompanied by the units. Kilometers canceled kilometers, divided by oh, this is in seconds. Seconds. It takes 3,600 seconds in order to in order for light to travel 7.2 AU. And maybe for the problem, maybe I'm even mean and I say, give your answer in hours. Okay, well now then I have to take the 3,600 seconds and convert that to something else. 3,600 seconds. To convert seconds to hour, I think that means I have to divide by 60, because I know that 60 seconds in 1 minute. So if I have seconds above, seconds below, that would cancel out, give me minutes, so I'm going to divide by seconds. And I know that in 1 hour there are 60 minutes. And then this minutes cancels that minutes, and so 3,600 seconds divided by 60 twice. 3,600 seconds, 3,600 divided by 60, divided by 60, and what have I got? I've got, count them, 1 hour. So exactly 1 hour later, I would see, exactly 1 hour later, my eyes would receive the light from this. If there was a space probe visiting this asteroid and gave us a signal, a radio signal traveling through space, it would take 1 hour for it to travel a distance of 7.2 AU. All right, there's one sort of problem. Let's do the other kind of problem. Suppose, okay, so that was finding time given distance and velocity. Now let's find distance given time. Suppose I look out there and I see that there is a comet out there that takes, it's so far that it takes, I don't know, 83 hours for light to get here from there. How far is it in AU? Okay? Identify the information you have. What information do I have? I have a time. I have a period of time. What's the information I'm looking for? A distance. I want distance given time, and okay, so far it takes 83 hours, for light. For light to get here. So that means I want distance equals velocity times time. All right, we put things in there. Velocity 3 times 10 to the 5th kilometers per second. We take time of 83 hours, and hold the phone. I can't multiply that because this is kilometers per second. But those are in hours, so what do I have to do? Before I do anything else, I got to convert 83 hours into seconds in order to do the calculation. 83 hours. Oh, I multiply by 60 twice. Again, look at this. 60 minutes is equal to 1 hour. 60 seconds is equal to 1 minute. So if I multiply 83 times 60, minutes cancel, hours cancel. I have seconds left. 83. I have 83 times 60, which is 298,800. Always write big numbers in scientific notation. 2.99 times 10 to the 5th seconds. We put, and there's the number we put in there. So I want distance equals velocity times time. That time is 2.99 times 10 to the 5th seconds. So now I'm actually ready to do the math. All right, here, let's start again. We're a nice clean board here. Distance equals velocity times time equals 3 times 10 to the 5th kilometers per second times 2.99 times 10 to the 5th seconds. I multiply all this out. I reach out for my handy-dandy calculator. 3 times 10 to the 5th times 2.99. Could round that to 3. That'd probably be fine. Times 10 to the 5th. And what do I got? I have 8.97 times 10 to the 10th. what would the units be? What are the units? Oh, this is kilometers per second. Per means divided by. Per second times seconds. The seconds cancel. That is an answer in kilometers. 8.97 times 10 to the 10th kilometers. Well, I didn't really need a calculator for that. This is about 3. This is about 3. 3 times 3 is about 9. 10 to the 5th times 10 to the 5th. Oh, I add the exponents when multiplying. Is 10 to the 10th kilometers. Didn't need the calculator. All right. So now suppose I'm mean for this problem and I say, now give your answer in AU. Okay, so now that I have the distance, I want to change it into a different units. I have 8.97 times 10 to the 10 kilometers, and now suppose the question says convert your answer to AU. Now I need to convert it. Oh dear, so how do I do this? I have that conversion factor. I know that 1.496 times 10 to the 8th kilometers. You don't have to memorize it, but know where it is. It's in your book. It's in the appendix. So the number of kilometers, 1.496 times 10 to the 8th kilometers equals 1 AU, 1 astronomical unit. The Earth is 1 AU from the sun, 93 million miles. So what do? I need to either multiply or divide this by 1.496 times 10 to the 8th. Let's try multiplying. If I try multiplying, I have 1.496 times 10 to the 8th kilometers equals 1 AU, and oh dear, look at this. This would be kilometers times kilometers divided by AU. Well, that means I'm not going to multiply. It means I need to take the number and divide it. 8.9, so this is wrong. Wrong. Okay, 8.97 times 10 to the 10th kilometers times 1 AU over 1.496 times 10 to the 8th kilometers. Does that work? Hey, it does. Look, kilometers here cancels with kilometers below, leaving me with units of AU. So that tells me that if I have a number in kilometers and I want to convert that to AU, that means I need to divide by 1.496 times 10 to the 8th. It means I got to divide by both of them. So in your calculator, you put parentheses around 1.496 times 10 to the 8th or divide by both of them. So I have 8.97 times 10 to the 10 divided by 1.496 divided by 10 to the 8th kilometers, and I get 601 AU. So if there is, this comet out there that's so far away, that must be a distance of 601 AU. So there we go. 2 examples where you had to do unit conversions on both sides of both examples, allowing us to calculate time from distance or distance from time.